Hi, my name is Nathan, and the topic of my group's project proposal is reinforcement learning for game balancing and bug detection. I will begin by briefly explaining our topic area. Seeing how games can be fairly intricate, bugs and imbalanced features tend to be quite common. Bugs can be defined as unexpected results that occur due to errors in the code of a game. These bugs allow for behavior that programmers did not intend for. Since there are many types of bugs in a game, such as graphical, audio, and text bugs, we have chosen to focus on one specific type, mechanical bugs. These relate to defects in actual gameplay, like players having the ability to phase through walls. Game balancing involves tuning aspects of a game, usually with the goal of preventing any of its components from becoming ineffective or no longer viable when compared to others. Gameplay is all about making choices, and in a poorly balanced game, many of the choices available to the player, such as which feature or strategy to use, are essentially rendered useless. The identification and correction of these imbalances is critical for customer satisfaction, especially with respect to games such as Dota 2, which involve high-level gameplay on a globally competitive scale. Testing is often one of the most time-consuming aspects of game development. Traditional approaches to game testing generally utilize a life cycle model, in which the tester and developer work together to ensure balanced and functional gameplay. However, more effective approaches to game testing have emerged in recent years, one of which is reinforcement learning. Reinforcement learning is a machine learning paradigm which solves sequential decision tasks through trial and error interactions with the environment in order to produce an optimal strategy. Reinforcement learning approaches are great for problems where not all of the information is known or available, perhaps due to insufficient domain knowledge or resources. This predicament is highly prevalent in many industries, making reinforcement learning extremely useful in areas other than gaming, such as robotics, chemistry, and advertisement. Since reinforcement learning is quite a complicated process, I've chosen to explain it using an analogy. Imagine a baby is sitting in your living room and is handed a TV remote. The baby will first observe and construct its own representation of the environment in its current state. Then naturally, out of curiosity, the baby will take certain actions like hitting the remote control and then observing how the TV responds. Through trial and error, the baby eventually presses the correct button on the remote, changing the state of the TV from off to on. The baby is now entertained, receiving a positive reward, and will thus take more actions that lead to even more entertainment, adapting its policy as these actions are found. This process is repeated until a policy is found that maximizes the baby's degree of entertainment. Reinforcement learning can also be applied to game balancing and bug detection. Like a baby, the AI agents will have insufficient knowledge of their environment, randomly interacting with it and observing how their actions manipulate the state of the game. Eventually, through trial and error, the agents will figure out which actions produce the greatest overall reward, adapting its policy to take into account the new actions. In some cases, agents discover bugs in the game that give it an unfair advantage over their opponents, resulting in an unbalanced but optimal policy being found. We have explored numerous literature which demonstrate reinforcement learning being applied to games. One of the earliest papers on this topic was presented by Grappel, Hebrich, and Gold in their paper Learning to Fight. They used reinforcement learning to train an agent to beat a hard-coded AI in the fighting game Tao Feng. The agent eventually developed policies that could be used to beat the hard-coded AI, achieving this by exposing weaknesses in the game engine and built-in AI. One paper which produced highly promising results was Dota 2 with large-scale deep reinforcement learning by OpenAI. They used reinforcement learning to train AI agents against current or past versions of themselves, then testing how well they would perform against human players. The agents were extremely effective, beating 99% of human opponents. The agents even discovered a new strategy which was so effective that the developers had to make changes to the game so that it would become less appealing. Promising results were also found in another paper by OpenAI, titled Emergent Tool Use from Multi-Agent Autocurricula. Reinforcement learning was used to train AI agents to play hide and seek. As the agents continued to verse each other, an unintentional bug in the game was found. The AI seekers discovered the ability to box surf, which enabled them to stand on top of a box and still push it around. This meant that seekers could jump over walls placed by hiders, proving to be a major advantage. It is evident that the current literature surrounding our topic shows great potential. However, there are a number of unexplored areas which have not yet been addressed. Kieran will explain one of them in the next section.
Thanks, Nathan. I'm Kieran, and for our proposal, I'll be looking at the gaps in current research, significance of our project area, and also our research aim and objectives. To summarize, Nathan, based on the research our group has undertaken, it is evident that the current literature shows promising results for applying reinforcement learning to games. The majority of the papers mentioned focus on the idea of using evolutionary algorithms to train an agent in order to beat certain levels within a game, as well as other players. What some of these papers have discovered through their research is that during the process of training an agent, the agent was able to discover bugs or imbalanced aspects of the game, resulting in the developers to have to reconsider features of their game design in order to make the game fairer. So, although some of the current literature does mention that as a result of applying reinforcement learning to games, bugs or imbalances in the game were discovered, there is a clear lack of research into utilizing the application of evolutionary algorithms and reinforcement learning in the scope of game development and testing. Given this gap in research, there is an opportunity to investigate implementing different reinforcement learning approaches on games. By focusing on approaches which generate agents that perform unusually well at a game, a review and analysis of the agent's actions within the game can be undertaken to give an understanding as to why they are performing so well. This could then lead to the discovery of bugs and imbalances within the game design, as the reason for an agent performing extremely well might be due to it abusing certain aspects of the game that are overly powerful or strong. Conducting research into this area is important as it has the potential to drastically help the game industry through the implementation of these new advanced testing methods. The methods may have the ability to identify bugs or imbalanced features within games more effectively than other current testing methods, resulting in more refined games and in turn higher customer satisfaction. Additionally, this research could also aid game developers and testers by significantly reducing the amount of time required for testing. As the agents are constantly being trained, the running time for learning and testing the game is able to be far greater than that of a human tester. Also, not only will these approaches be able to test for longer periods of time, they will also test and utilize every single aspect and feature of the game, ensuring the entire game is being tested. From our understanding and analysis of current literature, our project aim can be stated as the following. The primary goal of our research is to evaluate the performance of different reinforcement learning approaches when applied to balancing and bug detection in games. To help achieve this aim, we have broken it down into several research objectives, which are: how effective are reinforcement learning approaches for detecting bugs or imbalanced features, as well as which reinforcement learning approaches perform the best at detecting bugs or imbalanced metrics with regards to how effectively can they detect them, and also runtime and computational power. The first objective focuses on the comparison of reinforcement learning approaches with respect to current testing methods. To determine the effectiveness of testing methods, we can identify the quality and quantity of the bugs or imbalances that each method discovers. The second objective focuses more on the comparison between different reinforcement learning approaches. These approaches could be compared with reference to a performance metric. Possible performance metrics will be discussed later. Approaches can also be further compared by runtime and computational power, as if an approach has a significant runtime or requires large amounts of computational power, it could be considered impractical to implement. These objectives will help in achieving our research aim, as we will be able to identify the performance of reinforcement learning approaches in relation to game testing. I will now hand you over to Jamil, who will discuss research methods.
Hi, I'm Jamil, and I will be talking to you about our proposed research methodology. To accomplish our research aim and objectives, we plan on experimenting with various reinforcement learning approaches that have been shown through past experiments to produce skillful agents, as we believe these agents are more likely to encounter aspects of the game that provide an unfair advantage. Deep learning based self-play approaches, such as the one used by OpenAI for Dota 2, seem to be the most effective performance-wise. Other approaches that could be considered for experimentation include the MicroGP evolutionary algorithm, which was used for creating agents to play the online card game Hearthstone. We will also need to find appropriate games to test these reinforcement learning approaches on. These games will need to be competitive games, where the issue of game balancing is much more important. Dota 2 could be a possible contender, as highly powerful agents have been developed for the game in the past, and it is an extremely popular game. However, the complexity of the game makes it difficult to train high quality agents. Even with the resources of OpenAI, they were only able to train agents to play a restricted version of the game. So any experiments in Dota 2 would also have to be on a restricted version of the game. A much more plausible game to consider is Pokemon, specifically competitive Pokemon, where two teams of 6 Pokemon battle against each other. While there have been no prior experiments with applying reinforcement learning to competitive Pokemon, we do believe it is feasible due to the fact that competitive Pokemon only uses a restricted pool of Pokemon, and each Pokemon is only allowed to choose a limited number of moves, therefore making it much easier for reinforcement learning approaches to develop skillful agents. If we wanted to make the experiments even less computationally expensive, we could only have the reinforcement learning algorithms select from the most popular Pokemon used competitively, according to the data collected from websites such as Smogon. If competitive Pokemon was to be chosen as our testing ground, we would conduct our experiments using a web browser based emulator called Pokemon Showdown. As it is free to use, we would be able to run multiple instances of the emulator and therefore speed up the runtime for our algorithms. We will also need to select appropriate metrics to evaluate the performance of each approach. We propose both a qualitative and quantitative evaluation to gauge performance. As stated before, we believe the ability to discover imbalanced aspects of a game is correlated with the skill level of an agent. Therefore, we believe that average win rate will be a suitable metric for performance. We also want to look at the runtime for each algorithm, as long runtimes might make specific approaches less appealing to some game developers. We could also use human evaluations from experienced players of the games to manually review the highest performing agents in order to determine whether the actions they are taking provide an unfair advantage or if they are abusing any bugs in the game. In a world where games are becoming increasingly popular, and where players can make a career out of playing these games, it is crucial to have a game which is enjoyable by providing a bug-free experience and making sure that all possible actions in the game are appropriately balanced and do not provide an unfair advantage. However, most of the current state-of-the-art testing methods are conducted manually. Additionally, these methods are often time-consuming and not very extensive. While some research has been conducted into automating the process of detecting these bugs in game imbalances via reinforcement learning, the research is still somewhat limited. We hope to expand on that research further by conducting experiments with various reinforcement learning approaches on games such as Pokemon.